Well, Nathan, I'm very excited to be here to talk about minerals and rocks with you. And hopefully the students in the class will find that it's as exciting to them as it is to us. First thing is to try to figure out the difference between a mineral and a rock. And this is a rock. If you look carefully, you'll see that there's kind of some pink stuff in there, some black stuff, and some gray stuff. Okay, so each of those things that we see inside this rock is a separate mineral. And you notice that these minerals are actually pretty big. That will have some significance later on. If we were to extract those minerals from the rock, they might look kind of like this. And so here we see the pink stuff. That turns out to be a mineral that's called potassium feldspar or orthoclase. Two names for it. Potassium feldspar, of course, means that it has a lot of potassium in it. Now, this looks kind of clear. Some specimens will look more gray, like you have in here. This is a piece of quartz. And so quartz is made up of silicon and oxygen. It's silicon dioxide, one of the most important rock-forming minerals and very common. The black stuff is going to be either hornblende, which is this black one, or perhaps biotite. Now,
all right.
Okay, so let's come back to how we distinguish minerals from rocks. So a mineral is formally defined as a naturally occurring solid with a regular internal structure and a well-defined chemical composition that is inorganic. So what we mean by that is, some things are nicely crystallized, like proteins and other organic materials, but they aren't minerals because they're not inorganic. The well-defined chemical composition means that we're always going to find the elements in constant proportions to each other. Okay, and the regular internal structure refers to an arrangement of the atoms in a crystal lattice where they're regularly arranged, and that's going to lead to certain properties that we'll see as we demonstrate how you can identify some of these minerals. The rock, on the other hand, an aggregate of minerals. So lots of minerals in here, and you can see the pink feldspar, again, a black hornblende, and the pink potassium feldspar. Rocks can kind of fool you because it turns out that rocks do not have to have a perfectly well-defined composition. They do have to have a consistent set of minerals. But here, for example, we have two kinds of granite. This one you can see is a bit pinkish because it has potassium feldspar. There's another kind of feldspar which has sodium instead of potassium, and we call that anorthite. And you can see it here, but it's white. So without the potassium, it's white rather than being pink. Okay. Again, you can see in this granite, though, there's kind of a grayish quartz, and there's a white sodium feldspar. And here we have a black hornblende as well. So two different kinds of granites. Turns out this is the kind that you typically find in the Sierra Nevada if you go hiking. This one, you might see this more in the San Gabriels because granites are found in somewhat different locations and have a different chemical composition. Oh, here's another rock. You can't see the crystals. So rocks can be coarse grained or they can be fine grained. Here's another light colored rock. And again, you can see maybe just a few tiny little crystals in there. But for the most part, you know, these are crystals too fine to see with the naked eye. As opposed to these crystals that are big enough to see with the naked eye, and they may be several millimeters across. Why do we get a difference? Well, the answer turns out to be that in order to grow a nice crystal, it takes time. And so if you have a magma that's molten rock and you allow it to solidify, if that happens very slowly, then the different ions can diffuse to the minerals and make them grow very large. So this is a slow cooling rock. Here, it cooled so quickly we didn't have time to do that. We made tons of tiny, tiny little crystals because whatever ions were nearby, boom, came out, but we couldn't grow those big, beautiful crystals. So these are called extrusive rocks because they probably cooled very quickly on the surface. Intrusive rocks that cooled at depth in the earth where we had the layers of rocks above them that insulated them and kept them warm. What are the names? Well, turns out these light-colored rocks, this is a rock called rhyolite, and chemically it's very similar to this granite. So we say these are high silica rocks because they have about 70% SiO2 in them if we were to analyze the chemical composition. This rock is something called a basalt, and it cooled very quickly. Places like Hawaii. Oh, there we have magma that comes up from below. It's very rich in iron and magnesium. It only has about 50% SiO2, and so we get a different set of minerals that are dark in color. We say this is a mafic rock. Why mafic? Because the dark minerals have a lot of iron and magnesium. Oh, let's see, magnesium, Ma, iron, the chemical symbol is Fe. So put those together, mafic. And that's what this rock is made of. So these are more silicic, and we call these felsic rocks. Oh, because they have a lot of feldspar in them. They're rich in silica, oxygen, and aluminum.
So that's the composition, correct?
Yes, that's the composition chemically.
Felsic.
And you get different suites of minerals in this basalt. If we could look at the tiny little minerals that are in there, we'd see that there's a lot of olivine and some pyroxene, which is another dark mineral, and a bit of a calcium type of feldspar. So that's what we have in terms of rocks. Now, if we cool rocks really quickly, turns out that the crystal size is so tiny. Look at the difference here. Here you can almost imagine there are tiny little crystals. This is just a glass. And in fact, you make glass by cooling it quickly. This is a piece of obsidian, which must have cooled very, very quickly, maybe even in contact with water. Another thing that can happen is when magma comes up, it often has dissolved gas. And you can't feel this, but I'll tell you, it's pretty light. And in fact, it's so light, what do you think is going to happen? Well, we should do an experiment. We have two rocks. Okay, so here's obsidian. Here's this rock, which has about the same chemical composition. And let's see which one sinks faster. Wait a minute. That one, the little gray one, is not even sinking. Why? Because it's got tiny little bubbles all through the rock that are not wetting, and consequently, this rock is has such a low density that it will float on water, whereas the obsidian has a density of about 2.5 times water, or 2.7 times. So it turns out that actually density is a useful thing in thinking about rocks. This granite and this granite both have a density of about 2.7 times that of water, or 2.7 grams per cc. This basalt, it turns out, because it has so much iron and magnesium in it, makes minerals that are denser, and so its density is about 3 times that of water, about 3 grams per cubic centimeter. Roughly 10% more dense than the granite. And that will be very important to us as we discuss the behavior of materials in the earth. One more thing about rocks is that we use some of the terms for rocks in different ways. So we told you that this black rock is a basalt. And again, as you look at it close up, you can see that the crystals in there are really too small to see with the naked eye. However, here's another black rock that has identical chemical composition, but if you look carefully, you can see the minerals. And so this, yeah, you can see them pretty clearly on this side. So these are just big enough to see, and we call this rock a gabbro and this rock a basalt. But we also say that these are both basaltic in composition. Now, the minerals that you have in this rock, some are calcium feldspar, which can be a little dark if there are some inclusions in it. And we also have a lot of olivine and some pyroxene. And so together, those give you lots of little sort of blackish minerals, although the pure mineral olivine can actually be more yellowish and greenish in color. In the case of granite, we do the same thing. That we say there's granite, which refers to a rock with large crystals. And this is a rock called rhyolite, which has very small crystals, but they both have granitic composition. So we say granitic in composition, but this is granite, this is rhyolite.